Modern AI systems often convey information with remarkable fluency and confidence, yet can err dramatically, producing authoritative-sounding yet incorrect outputs. This paradoxical behavior, known as hallucination, sits at the heart of contemporary debates about AI reliability. And deeper analysis uncovers the true nature of machine intelligence. Hallucination is the emergence of information that is fabricated or otherwise unsupported by data. The model's output is not a deliberate falsehood. Rather, it is a consequence of its core mechanism. It outputs the statistically most probable next word or phrase based on its training, not on truth verification. Fundamentally, AI systems are probabilistic prediction engines. Unlike humans who reference facts, they string together likely word sequences. This predictive nature allows models to craft coherent responses without establishing factual integrity, creating a tension between fluency and correctness. AI systems do not possess a database-like repository of facts. Instead, they encode vast webs of statistical associations harvested from training data. Thus, when asked to evaluate or recall facts, they depend on pattern matching, not direct retrieval, which can yield inadvertent errors. The scope of an AI's knowledge is bounded by the completeness and quality of its training data. Gaps and omissions in this data can result in the model filling in blanks with plausible but inaccurate information. Hallucination thus becomes more likely with underrepresented facts. Absent certain details, AI models tend to generate plausible completions for missing information. This extrapolation underlies both their creative abilities and their propensity for convincingly stated inaccuracies. AI does not discriminate between certainty and uncertainty in its outputs. Every answer is delivered with the same tone of confidence. This masks underlying guesswork, making it difficult for users to discern between validated knowledge and speculative output. The capacity of AI models to generate linguistically fluent responses adds an additional layer of complexity. High-quality language production can obscure errors, causing users to overlook factual mismatches in otherwise well-phrased answers. Unless explicitly designed with verification layers, AI models do not independently check factual accuracy. Most rely solely on internal pattern completion, leading to increased hallucination rates for complex, fact-based inquiries. When posed with vague or insufficiently detailed queries, AI often resorts to hypothesizing details, increasing the probability of generating inaccurate answers. The model's lack of authentic context awareness makes it prone to error under ambiguity. The risk of hallucination rises when user queries are imprecise, forcing the AI to interpret intent. This process often leads to misalignment between input intent and generated output, especially when multiple interpretations are plausible. AI's tendency to generalize from learned patterns means correct information can be misapplied. This generates responses that are partially accurate but contextually off-target, further blurring the boundary between truth and error. Each AI response is formed sequentially, one token at a time. Early inaccuracies can cascade, leading subsequent tokens to reinforce and compound initial mistakes, skewing the overall answer. Mistakes within a generated sequence are rarely corrected mid-output. Instead, the model builds upon erroneous premises, propagating and intensifying the problem as the response unfolds. Even with external retrieval mechanisms, hallucinations persist if the system cannot access relevant data, forcing it to revert to probabilistic guesses rather than grounded retrieval. Incorrectly ranked retrieved data can mislead the model, leading it to use irrelevant or misleading information, which results in factual distortions within the output. Real-world datasets are rife with noise, inconsistencies, errors, and stray facts. AI models sometimes learn these flawed associations, manifesting as hallucinations in subsequent generation. While fine-tuning narrows error margins and improves specificity, it cannot fundamentally eliminate hallucinations. The probabilistic nature of the generative process ensures that mistakes, albeit reduced, persist. Reinforcement techniques refine the output toward helpfulness or coherence, not absolute accuracy. Thus, while responses may improve in utility, factual correctness is not strictly guaranteed, allowing hallucinations to remain. Consequences in critical domains such as healthcare, finance, or law can be severe. Reliance on hallucinated outputs without rigorous verification can lead to detrimental decision-making, underscoring the need for caution. Identifying hallucinations is difficult, as fluent responses often mask errors. Users typically require external sources or domain expertise to validate AI outputs effectively. A critical evaluation by users is thus essential. Treating AI as a tool, not an infallible oracle, mitigates risks inherent in relying on probabilistic generation. Clear and specific prompts guide models to more accurate outputs. Strategic questioning reduces ambiguity and helps limit hallucination rates, improving both relevance and correctness. Integrating external real-time data sources anchors AI responses in factual reality, effectively reducing the frequency and severity of hallucinations. Systems with built-in validation mechanisms further enhance reliability, cross-referencing model outputs against trusted sources prior to dissemination. Ongoing research strives to improve architectures and training processes, advancing toward reduced hallucination rates. However, the challenge remains formidable, and progress incremental. Reducing hallucinations often entails sacrifices in creativity or flexibility. The optimal balance between accuracy and useful improvisation is a keystone objective for AI developers. Next-generation AI systems will lean heavily on enhanced retrieval, verification, and reasoning capacities, striving to minimize hallucination and foster greater trust. Hallucination is not intentional deception, but a natural byproduct of pattern prediction. Understanding its mechanism dispels misconceptions about AI motives. Comprehending the risk and cause of hallucination sharpens our appreciation of AI strengths and weaknesses, fostering more effective and accountable usage.